and that we have 16 elements there, we would like to find whether the element 22 is there. Okay, so because the sequence is sorted, yeah, so the best is go to the middle, right? The middle, and to check whether we should go to continue our searching on the left-hand side or right-hand side. Okay, so iteration 1 will be try to locate the midpoint of that. The midpoint, how do we do it? You have 16 elements, 1 plus 16, add them together, 17, right? Divided by 2 is not equal to 8.5. You use the calculator. You always trust the calculator. You don't believe in yourself, right? So you get 8.5. But actually, we are talking about the index. Yeah, so it should be rounded to 8. Okay, so this is 8. So we will compare with the value number 8, which is 14. So our key value is 22. So it's bigger than 14. So we don't need to search for the left-hand side, right? So we go to the right-hand side. So we continue our second round of search. So the second round, you see that our focus will be on number 9 up to 16. Yeah, because the left-hand side, we don't care because cannot be there, right? So we also find the midpoints. So the 9 plus 16, and you add them together and divide by 2. So is equal to 12. So you compare to the element 12 here. Okay, so 12 here. So since 22 is smaller than 25, right? So we'll go to the left-hand side of that. The left-hand side of that, you see that will be number 9, number 10, and 11, right? On the left-hand side of 12, but more than the previous midpoint. Yeah, so should be these 3 numbers. We continue to do it. We'll find the midpoint. The midpoint is 10 this time, right? And the key value is 19. So 22 should be bigger than that. Then you go to the next one. You have only one value. Yeah, so you compare with your key value is there. So you get 22. So you know that here for this case here, we need about 4 rounds of search. Yeah. It may be true that this is roughly the worst case. If we cannot find it, yeah, if the 22 is not the one we want, let's say like that, then we will return another value, -1. -1, as you see that we are talking about an array, right? So -1 is not possible. It will inform the calling party, yeah, because the one who issued this function said to search for that, we cannot find -1. So -1 will be the return value if we cannot find it. If we can find it, will be from 1 up to 16. So it's okay. So you see that for this particular one here, if you take the log of 16, you will need 4 rounds. Yeah, so actually it's the worst case already. Cannot be worse than that. As you can see that we are very unlucky. So until the last one, we find the guy. Is it? So 4, because you take the log is 4. So roughly will be like that. Okay, even you find it, you don't find it. Yeah, so 4 rounds. Yeah. Now, if you use the linear search, you will look at it. Number 1. And then number 2, number 3, and so on. So you will find the one, or you will find one after you compare 11 times, right? So that is quite long because, and the worst case if it's not there. If I want to find something which is not in this group here, then we'll go to the end 16 times, right? So it's much worse, and very often we cannot find. Yeah, from practice, right? Yeah, you know that most of the time we search maybe the name, you see it's capital letter or lowercase, or you misspell something, yeah, you cannot find it. Yeah, so you return -1, cannot find it, right? So that is quite long. Yeah. So this binary tree, you can see that is advantage. Yeah. It's roughly log n. Okay, log n is the height of the tree. Okay, now it's the height of the tree. Yeah, if you put 16 elements there, if they are sorted, yeah. Okay, so the remark here is very clear. So I will leave it to you lah. So this time we use the binary search, should be faster. Okay, any questions here? So how about the online student? Any other comments here? So the 4 here has some meaning in the background, is the height of the tree. Height of the tree, huh? Yeah, so it's not from nowhere. It has this very, very deep meaning here. Okay, and then you use linear search, whether say that, oh yeah, because you are dumb, you see, you check it from the first one to the last one, or you can check it from the last one to the first one, and you're faster. Well, God knows, right? This one, yeah. So on average, you have to search half of them 8 times, right? Before you can find the guy, find the key, right? But here, worst case, even the worst case, yeah, because we can do it. Because what's the why we can do it? Because the sequence is sorted. So we have to do some initial so-called work to arrange the sequence. If we don't do it, we don't get this advantage. Yeah, we have to use the linear sort, right? Okay. No comment, then we move on. How about that? Today a little bit fast. Only five questions. Yeah. And then they are relatively easy to understand. Yeah. So Lex. So Lex is quite related to question 1. Is the algo for that. We would like to write to implement recursive implementation of that. Okay, so the algo is quite straightforward. First of all, we have an array. The starting point is I, the ending point is J, and we have the key, right? The target for search. That is 22 from our last page here. So output will not be 22 lah. So because we know the value. Okay, so should be the index of this key here, the index. Sometimes we cannot find it, we have to return -1. So that one is quite straightforward. Yeah. Okay, so the algo is called B search. A is the array, the starting point, the ending point, and the key we want to search for. Okay, so first of all, we will expect that I will be the starting, J will be the ending. I and J, I should be smaller than J. If I is greater than J, come on, yeah, so something wrong. Return -1, you cannot find something wrong. Right? Your starting point should be smaller than the ending point. Yeah. Okay. So we would like to find the midpoint. The midpoint will be the starting point and the ending point. Add them together, divide by 2. If the key value we would like to find is equal to that particular midpoint value, we hit the jackpot, then we return the index of that. That is K lah. That is the K. We hit the jackpot. Yeah. Okay. If we cannot find it, we have to decide whether we go to the left-hand side and to the right-hand side lah. If the key is smaller than the midpoint value, we go to the left-hand side. So for the left-hand side, we start from I, but the ending point will be smaller, half of the elements, right? K minus 1. Then the key will be the same as before. If the one is greater than that, we'll go to the else statement here. So we have to continue to search. Yes, you see that this is a binary recursive search, right? A here, the starting point will be the right-hand side, K plus 1. And the ending point will be the same, and the key value should be the same. So all of them. So it's quite straightforward, this one. So any comments on this? This is a recursive way to do it. Okay, so online students, any other comments here? So you try to, when you write the algo, I know that you are very smart, I know what you mean, but you have to write down some comments on that, No comments, sometimes I cannot appreciate your wonderful algo. Okay or not? So I also need to tell you that, I find the midpoint, I find the target, we go to the left, we go to the right. Something very simple, no need to be very detailed. Then I understand your flow of algo. Okay or not? Because you always very neat, too neat. It's not very good for me lah. Okay or not? So try to help me. Okay, so we move on. How about that? So today should be faster lah. So this one is even faster. So we are given a graph. The graph has 2 types. We learned it there. One is unidirectional. So this one is you look at the length here. So something like that. From 1 you can go to 2. From node 2 you can go back to 1. No restriction. From 3 you can go to 5, and then from 5 you can go back to 2, something like that. So this one is no direction. Okay, no direction. So when you represent the connectivity of the graph, we have introduced 2 of them in our course. The first one is the linked list. So normally the single linked list SLL will do that. If you don't know what I mean SLL, then you need to review it lah. Right? So I have drawn some diagrams there. So should help you to do it. Another way is the linked list. Now, so when this one here, we are talking about SLL, single linked list. So this kind of diagram is called adjacency list. So this is plural. Why we use plural? Because we count this one. The first one start from this pointer here is one linked list. Then the second linked list is this one, and the third and fourth and so on. They are all together 6 linked lists here. So it's a plural. So sometimes you have to read a little bit more. Don't say that, oh, this whole thing is called linked list. No, individual one is a linked list. Yeah. So the total of them, the totality is the adjacency list. So another way to present this one is called the adjacency matrix. Later on, you'll see that how to do it. Okay or not? So you have to know unidirectional, directional of graphs. When you represent the connectivity of them, you have to understand that we have the adjacency list using the single linked list to represent it. Another way is to use the matrix to do it. Then you read the books, then we'll talk about that, which one is good, which one is bad, right? Actually, in general, this guy is faster because you see that, it's easier, yeah. This is easier to use the adjacency list. But the matrix is clearer. Sometimes it's clearer. Okay. Anyway, yeah. So the questions ask you to do the adjacency list. So how do we do it? Now, so first of all, we have to have an array. See this one, the array, the size of the array is 6. Why 6? Because we have 6 nodes. We have node 1, node 2, node 3, up to node 6. Altogether, 6 nodes here. From each node here, we have an arrow here. These are pointers. These are pointers. So we have an array with n elements, right? N dot last or at j dot last. Yeah. So we have 6 nodes. We have 6 elements here. Each one of them is a pointer. Each one of them is a pointer. So this pointer number 1 from this array element here, you see is a pointer. It points to the start of the linked list associated with A. So from 1 you can go to 2. So it's here. From 1 you can go to 4. So your 4 is there. From 1 you can go to 5. Here. You can only go to 3 different nodes. From 1 you can go to 3 of them. Okay. So don't read it like that, yeah. From 2 you can go to 4. From 4 you can go to 5. This is totally wrong. Totally wrong. Okay, now this one tells you that from 1 you can go to 3 different nodes. They are from the graph. It's clear that they are linked to node 1 here. So this is the first linked list. The second linked list will be from 2, right? From 2, obviously, you can go to 1, you can go to 3. So you can go to 1, you can go to 2, to 3. So this one here, where do we hold them? This is a single linked list. SLL. Single linked list has 2 components, right? The first component is the data. This data will hold the value 1. So that means I can go to 1R. From 2, you can go to 1R. From 2, you can go to 3. So obvious from here. So this 1, 3 here are data, are the data component of the node, right? Another one is the next part here, the next field here will tell you who is the next one. Connect to that because it's SLL, right? So here, and then the last guy, you terminate that. That means, oh yeah, only two of them. You use this one as the indicator to know that, oh, this is the last one. Oh. So from 2, you can go to 1. From 2, you can go to 3. So all this value, 1, 3 here, are the data component, data field of the SLL. So you know a little bit the structure of that. So it's important. You go back to review that, the SLL. It has two fields, two parts. The first one is the data. So you use the dot notation to be this node dot data is equal to 1. This node dot data is equal to 3. Like that, Okay. So the others are also pointers. So this is the pointer point to 4 of them. So number 3 can go to 4 different places. Can go to 2, can go to 4, can go to 6, go to 5. Obviously, can we write it in another way? Go to 6, and then go to 5, and go to 2, and go to 4? Yes, you can. Here, I do it from so-called bigger and bigger, the node number, right? This is not necessary. So if somehow you look at it, wow, in the exam, this question, how come this one is linked from 6, can also go to 4 and go to 2 and go to 5, like that in so-called this order. Yeah, there's no order. Up to you. I just do it like that. You see, it's arbitrary. There's no rule saying that you have to do it from small to big, the node number, right? No need. It's up to you. Okay or not? So you have to know a little bit more. Okay. So this one, do you have any problem? So here you know that it has 2 parts. The first one is an array called ADJ, adjacency array. This array is holding pointers, and each pointer is pointing to SLL, and SLL here. So you know the structure. You have to know the structure of that. What's SLL here? The data part, the next part is also another pointer. So the pointer, the last one, you have to terminate that. Terminate, you can put it like that. An arrow go to now. Also can. Different way to do it. Yeah, this one I'm lazy. I just terminate like that. Also quite commonly used, as long as we understand it. So any comment on that? So I spent some time to give you more information about this array here. So you have to know that I put it like that is not just I draw it beautiful, right? Beautifully. No, it is an array. An array has n elements. Yeah, what's n? N is the number of nodes you have, and each one is a pointer. A pointer points to this linked list. Okay or not? Any comment? If you understand it, very good. If you don't understand it, go back to review all these key concepts, right? What's the pointer? Pointer is an address, right? Tell you where to find the linked list. And each linked list, what's the structure of that? So this one is SLL. Yeah, we have another one is W. So you have to know that you can go back. This one cannot go back. Okay, so I think enough lah. Okay or not? Next. Next is called digraph. This one is a directional. So you look at the diagram is the graph is like that. From 1 you can not go to anywhere. No way, because the arrow here. Number 2 you can go to 1. That's all. Number 3 you can go to 2. Number 4 you can go to 5. But from 5 you cannot go back to 4 lah. 5, 6 can go to 2 places. 1, note 1 and note 7. And 7 go to 2 different notes, number 2 and number 3. So they are directional. So here. So the linked list will be more or less the same, but simpler, right? Because it's directional, right? So you cannot say that 1 and 2. From 1 you can go to 2, 2 you can go back to 1 or whatever. Cannot, you have to look at the arrow. So from 1, where can you go? You cannot go to anywhere. So that the pointer here is now. The pointer here is now. Point to nowhere. Okay, number 2. It can go to 1. So you have the linked list is very simple, can only go to 1. Number 3, you can go to 2. So like that, the pointer will go to a linked list, but the linked list only has 1 node. Yeah, only 1 node. Okay, 5, you cannot go to anywhere. 6, you can go to 1, you can go to 7, right? Go to 1, and also you can go to 7 after that. So if you put 7 first and then 1, can. Same. No difference. Okay, this one is from 2 to 3. Okay, yeah, so I think it's quite obvious. So the structure will be the same. You have the adjacency array. This array is n pointers, right? N is the number of nodes in this graph here. They are directional. Yeah. So this one, if you understand the previous one, right? I spent some time on that. Yeah, then this one should also be quite easy to understand. Okay. So any comment? Online students here. Do you have any additional comments on that? Okay, done. So we move on. Number 4. Number 5, you see, very good, right? The last one. I believe it's the last one, right? So this one here. This one here. Okay. So this is the whole degree of a digraph. Okay. So this one here is like this. So you also need to know what's the out degree. Out degree. How many nodes you can go? So you see that for 1, can you go to anywhere? Cannot. From node 1. So the out degree is 0. Can we say that? Out degree. How many nodes you can go from 1? It's 0. Because you can see that. Another way is, and another one is the in degree. How many nodes can go to number 1? So you look at it, from 2, you can go to number 1. From 6, you can go to number 1. So the in degree of node 1 is 2. Okay or not? One more example. Number 3 lah. Number 3. Number 3, you can see that the in degree only from 7, right? So in degree is 1. In degree is 1. Out degree also 1, right? From 3, you can go to out degree is 1. So number 5 is like that. You are given a digraph like that. You have to find the in degree and out degree of every node. So you have 7 nodes here. Then you should have 7 sets of results. So like node 1 in degree is 0, 2, out degree is 0, right? Then node 2 or vertex 2, the in degree is 2, right? The out degree is 1, like that. You have to report 1 by 1 for 7 of them. Why 7? Because you have 7 nodes, 7 vertices. Okay or not? The most difficult part is for this one here. The most difficult part is the in degree is very easy. Sorry, the out degree is very easy. Just like number 3, the out degree where you go, you see, you look at it, you have only 1 node connect to that, so it's 1. How about 6? 6, you can go to 1, you can go to 7. It's here. You count 1, 7. Then it's 2 lah. The out degree is quite easy to find. So you count the linked list associated with that particular node, right? You know the start, the pointer, right? Then you count number 1, number 2, right? So once you go to the terminator here, the last one, then you stop that, then you count it all 2. Okay, that one is quite easy. Another one is the in degree. How do you get the in degree? From here, how do you get the in degree? Think about that, you see. This is a very real exam question, right? How do you get the in degree? How do you get the in degree? So you get the in degree of 3 like that. How do you do it? You have to examine all of them. Once you can, so which one is associated with 3? Only this guy here, right? Only this guy here. So you know that the in degree is 1. So you have to, first of all, you have the counter. The counter is counting the in degree of that. So you have to check 1 by 1. Which one, the data part, right, is equal to 3. If equal to 3, then you update the counter, right, from 0 to 1, right? Okay, now. So how about 2? 2. How do we know the in degree of 2? So you have to check all of them. This one not associated with 1. This one, the data part is 2. Then you update it from 0 to 1. Then you check all of them. Come to here. The data part is 2, right? Then you update it from 1 to 2. So altogether you update 2 times. So the in degree should be 2, associated with 2, correct? Okay or not? Think about that, Before you see my answer, you should do it. I give you 5 minutes to do it. You cannot finish this one. You cannot go to the exam hall. Cannot survive there. Cannot survive there. This kind of question is roughly the standard, the level. So we will give you some mark for out degree because we understand. And also you need to have some intelligence, right, to find the in degree. So how do we do it? First of all, you have to set up the in degree counter. How many of them? 7 of them. All of them should be 0 at the very beginning. How about the out degree? Also the same. At the very beginning, you initialize it should be 0. So you have 7 in degree counter, 7 out degree counter at the very beginning, right? And you initialize it. Initialize it means set them equal to 0, right? Then we go to check the first one. So you use a for loop to go from 1 up to the 7, right? So for 1 here, for one of them, any one of them, then you will see that is this one now? Oh, no, this one is not now. Then you go to see if this one is not now, you update the out degree associated with that, right? You update the associate the out degree of 2, and then you look at the data part of it. The data part is equal to 1, right? Then you update the in degree of 1, the counter. Then you continue to the next node, but this one terminate, no need to do. Just like here, if the one here from 6, so you see that from 6 you see 1, so you update the update means you add 1 to the out degree counter of 6, right? From 0 to 1. And next, you check the data. If the data is equal to 1, then you have to update the in degree of 1. You add 1 to it. Then you see whether the next is equal to the terminator. If not, then you go to visit the next one. And the out degree should be increased by 1. So you have 2 nodes here. And also use, so you also look at the data. The data is 7, right? So the in degree of 7 should be increased by 1. So every node, once you see it, see the node, update the out degree. Look at the data, update the in degree, right? Then at the end, then you collect all of them in your counter, right? Then you use the print statement to print them out. And that's all, right? Okay or not? So roughly you know the idea of that, right? You have to implement it using the pseudocode. Okay or not? Now, so okay, 5 minutes so I give you the answer The answer is like that, as what I say, that this one here. So first of all, we have to know how many nodes we have. ADJ.last is this array, how many elements there, right? So each one is holding a pointer, right? N of them. So we'll create the counter for that, for in degree from 1 up to 7. The out degree from 1 up to 7. All of them initialized to 0. So we have 14 counters, right? 7 of them for in degree, 7 of them for out degree. All of them initially should be 0. Okay. So this one, you have some marks. So you see that, Then I start to look at each one of them, each of the linked lists, right? You have the linked list, one of them. Okay, from I equal to 1 up to 7. So we get the reference point is the head, the pointer, right? You get the pointer. Where do you get the pointer? You get it from the array. The array is holding the pointer at the very beginning, right? So it's very simple. Okay, so you have to check whether the pointer is pointing at now. If it's pointing, it's not equal to now, then you need to update that. So So once you see a note there, you update the out degree counter. You add 1 to it. The in degree counter, you need to look at the reference, the pointer dot data, right? The data part of that. So once you see it, you update the counter of that. Okay or not? Reference dot data. If this one is you totally cannot understand it, then I totally cannot explain to you. You have to know what's the SLL. SLL has 2 components, right? 2 fields. The first one is the data. The second part is the list, right? Is the pointer. We are talking about the first part. Oh. Okay, so once you update these 2 counters, you go to the next node. Reference is equal to the reference.next. You use the dot notation because we are talking about an object. The pointer is pointing to an object. The object, we want to know the data part, we use the dot notation. Okay, dot notation, dot notation because it's a pointer. It has 2 fields, right? So we simplify it like that, dot next. So we do it one by one, from 1 up to 7. So we update all the out degree 7 counters one by one, the in degree counter one by one. Once we finish it, we have to print the result. To print the result is up to you how to do it. Here I introduce the print statement and the print line statement. The print statement is like you continue to print something, right? Print line is you finish it, you go to the next line. You have a carriage return at the end. Okay. First of all, you see that with the code here, the vertex I is a variable. Can be 1, can be 2, can be 3, can be 4, and so on. I use a plus here. Doesn't mean that you print the plus. It means first you print the vertex, and then you have an I. So you have to add this together. Add means this is the first component, this is the second component. Yeah, you don't need to do anything. Okay, so this plus here will not be printed. So the first you print the vertex, this word here, and then you print the variable values. I can be 1, can be 2, can be 3, can be 4. Then the third one is also 2 words, has in degree and the value of that. But after that, we don't go to the next line. We continue to print. We continue to print. Then we say that and out degree, what's the value? So all of them, we use the plus here to join them together. But the plus is just a symbol. Tell you that this is the first one, and then this one, and then in this one. You will not see the plus sign, this symbol here. Okay or not? So you have to know that the print up to that, we don't go to the next line. We continue to print this one. Because the line is too long, I cannot put it in one single line. Right? So that's why I do it like that. So the sample output will be like that. So you will exactly see something like that. From the figure 2, you look at the diagram. Vertex 1 has in degree 2. So you don't see vertex I. Don't you see the plus sign? You don't see it. And then plus has degree. This is the value. And so we will not go to the next line. And out degree 0. So this one, you look at the print statement and print line statement and compare to the output. Surely in 10 seconds, you know what I mean. You can compare, right? You know the answer, right? So you know what I mean. So you know how to do it. If you're still not very sure, Google it. Google the pin in pseudocode, the pin line in pseudocode. Then the one will tell you how to do it. Okay, now they also use plus. They also use plus, right, in pseudocode. Okay or not? Yes. Pin line. Pin line means a carriage return at the end. You go to the next line. Pin and then go to the next line. Pin line. Okay. You look at my sample output and look at the print statement. Immediately, you will see you will solve all your problems. Okay or not? What's that? Yeah, ask me. Yeah. This is 10 seconds. Yeah, go home. You have a lot of doubts. Yeah? So you ask me 10 seconds. Yeah. Any problem? Okay, online students. Any problems? I don't guarantee the answers are right. I check it 2 times. This is new. I just add there. I think I added there to be easier. So the other class they don't see it. The other class they don't see it. Yeah, I just did it 1 day ago. Okay. Any questions? Today is not very difficult, right? Go back to write your own in degree, out degree. This algo. Make sure that whether you memorize it, you did it, whatever, make sure that you understand it. Okay or not? Okay. No questions? Thank you very much. So today we end here. So online student. So you can see that. So I think I have explained everything in this one here. Is the for loop here. Okay, so I stop here. Thank you very much. Yeah. Later on, I receive the link. I will share the link with you. Thank you very much.